Hello guys, and welcome to the 2021/2022 Physics Practicals 2, which is Physics 104 graph solution. Now for today's class, we'll be looking at how to plot the graph of the physics practical. Now the question here says, to determine the internal resistance of a cell, a student obtained the following results from an experiment. So you can say the student did an experiment involving current and voltage, and the value for the current and voltage for each point picked is given in this table here. So when the current was 0.1, the voltage was 1.36. When the current was 0.20 amperes, the voltage was 1.25 volts, and so on and so forth. So you have this. Now the A part says plot a graph of voltage against current. B says determine the slope of the graph. C says determine the EMF, which is electromotive force of the cell. D says determine the internal resistance of the cell. Alright, so let's get this done. So our first question there, A, says plot a graph of voltage V against current I. Alright, so let's get this. So go to our graph sheet. I'll pick up my graph sheet, and so if I look at this from my current there, my minimum value of current is 0.1 amperes here, and my maximum current is 0.6 amperes. You can see here. My minimum voltage is about 0.86. So here's my minimum voltage at the end here, and my maximum voltage is 1.36. So you have to pick a suitable scale so that you can plot this properly. So I'll go to my graph sheets that's here. Alright, so I'm here. So you can see this here. I've already done my graph. You can see how it picks my scale. So you can see why I picked my scale here. My voltage is having 1.6 maximum there. And we know that for voltage, the highest value was 1.36. So that can contain it. Also, if I move to my current, so I'm moving my, look at the current here. The current here, the maximum here is 0.6, which is almost the same thing as what we had from our table there. So my task will now be now to now plot each of the points on this. So just choose each of the points. So when current was 0.10 or 0.1, that's this point here, 0.1, the voltage was 1.36. So use your graph sheet to look for 1.36 and then pick the point. But I'm simply going to do this on this software. So I'll just come here and put my points in here. Alright, so one thing before this, also remember that from my question here says plot a graph of voltage, so you can see here, against current. Please, for a graph of voltage against current, the voltage here will come on the y-axis. So the y-axis becomes the voltage and the x-axis becomes the current. Alright, so you can see that in my graphical work. You can see that y-axis is voltage V and x-axis is current A. Also observe that since I've imputed V, that's the unit of voltage, as volts, and unit of current as amperes here, I don't have to start writing 1.4 V or 1.2 V. It's not important because the units has already been included here and here. Alright, so I'll just go ahead and then pick up my point. So at this point, just pick out your points where 0.1 and the current axis, that's here, and then 1.36, somewhere around this point here. From your graph sheet, pick out your points. For me, I'll just simply impute them. Come here. Alright, so X, don't forget X is my current axis. So when the current was 0.1, the voltage was 1.36. 1.36. When the current was 0.2, my voltage was 1.25. Alright, so I'll just go ahead and do this very fast so we can get our points. At this point, I'm done imputing all the values for the current and the voltage. I'll just go and OK this. Alright, so if I look at this now, if you observe from my graph here, you would see that this is not a straight line graph. And of course, we can't plot a graph like this. Like if I look at my points, 1, 2, 3, 4. So if I try to connect my points now, I won't get a good straight line. So what I'll do here is very simple. So instead of doing this, I'll take a line of best fit. So please, in your graph work, please, you don't connect it like this. Instead, you look for a line of best fit. Let me show you how a line of best fit works. So I'll just pick here. So this would allow me to take a line of best fit. So okay, this so you can see this is now my line of best fit. Let me take off this one so you can see properly. All right, so you can now have this. So this is now my line of best fit. So this is what my line of best fit looks like. All right, I think this should be your graph for that question. Let me zoom out a bit. All right, zoom out a bit so you can see properly. All right, so this is what your graph should look like. Yep, if you plot it properly, you have a graph like this. All right, so this is what my graph would look like if I plot properly. All right, so I'm done plotting a graph here. Now, something there, when you plot a graph, or for the A parts, for every graph sheet, two things are important there: the title of your graph and the scale of your graph. So please, your title of graph and scale of graph must be included, all right, in your graphical work. So I'll go and impute this. So for this one here, let's look at title of the graph. All right, so first things first, let's include a title. So the title, excuse me. So my title of this graph becomes if I look at this, I was asked to plot a graph of this. So my title should be this: title graph of voltage against current. So that becomes your title. I'll just bring this here. So it becomes this, right? So that becomes your title. So I'll change this to capital letter. All right, so that's a proper punctuation. So the title becomes graph of voltage V against current I. So I've gotten my title. My next task is scale. All right, so every graph must have a good title and a good scale. So let me include my scale here. So scale used, just come here, scale used, scale used, scale used. So let me go back and see what scale I used here. So for this, now note that when it comes to picking scale, from this point where this mouse is, from here to here is called a unit. So from here to here is called 1 unit. From here to here is called another 1 unit. So from this point here to 0.1, they have 2 units there. But then for what I have here, from here to here is called 1 unit. And 1 unit represents, from my graph here, I have 0.05, and the unit of the current axis is what? Amperes. So I will say let 1 unit, that's from here to here, be equal to 0.05 amperes on the current axis. So amperes here on the current axis. So I'll go here, right under my scale use, I'll say let 1 unit be 0.05 amperes on the current axis. Okay, and let's now get for the voltage axis. So let's see what I have there. For voltage axis, which is the vertical axis, I have from here to here is about 0.2. 0.2 is in volts. So I'll say let 1 unit be equal to 0.2 volts on the voltage axis. So it becomes this. So and let 1 unit be 0.2 volts on the voltage axis. All right, so I have this. So with this now, I have successfully imputed my title and my scale used. All right, so having done this, we are done with the part 1 of the question, which says plot a graph of voltage against current. That is done. The B part now says determine the slope of the graph. So I have to go back to my graph and get my slope. So just come here, slope. So I have slope. Okay, so let's get my slope. So I have slope is equal to, all right, let's see what I have for my slope here. The good thing about this software is that it automatically calculates your graph and your slope for you. If you can remember the equation of a straight line, it's mx plus c. So from here I can see that the slope from here, you can see from here where my mouse is. Okay, let me bring it here. Okay, let me move this a bit so you see this. All right, so you can see that equation of a straight line is mx plus c, where m is what there? The slope of your graph. So from here, it says my slope is 0.9886. That's like my slope, all right? but you're not using the software. So how do you get slope on your graph work? So what you do is this. I'll just simply come from here to get your slope. You look for the point where this your line cuts the x and y axis together, just like this point here. So here is a good point for slope. So here, if I look at this, the x-axis here is about 0.05, and for the y-axis, that's the voltage axis, that's about 1.4. So here's a good place to pick a point for a slope. But I'll just do this. So 0.05 and 1.4. Okay, so 0.05 and 1.4. So I have this. Okay, this. Let me okay. So I can see, okay, so I can, okay, this there. All right, so you can see this is the point I'm talking about. So you can pick this point for a slope. Also, you can look for something similar to this. That's where this line cuts x and y axis. So here is good, but here is too close. So let me come down a bit. Is there somewhere down that I can use? Here, but here is not that perfect. You see, there's a space here. There's a space here, so here is not that good. So look for, so here is more like, here is perfect too. So fine, let's stick here. All right, so I'll come here, this, and I'll pick this point. All right, so you can see this. Then next up, I'll now take the where this and this meets. So I'll trace this to my vertical axis. That's voltage. That's this point here. I have this, and then trace this upwards, and then I have this. All right, so you can see this. So this is how you pick slope. All right. The major focus now is that you pick slope at this point here. That's where this line cuts x and y axis, where they cut all that's here and then here. So that's why I picked up my axis. All right. So I have this. So let's calculate the slope. Already, as I said, this already calculates slope for you. It got my slope as 0.9886. So this is like my most accurate slope. But let's just do a manual calculation. Let's get slope here. So my slope is equal to, I'm just going to insert, of course, change equation. Okay, structures. I'm going to insert this. So slope, of course, we know is equal to excuse me. So equation structures this. So slope, as we know, is equal to change in y over change in x. But now I'm not working with y and x. I'm working with voltage and currents. So my y-axis is voltage. So I'll say change in voltage all over change in current, please. All right. So change in voltage all over change in current. Let me insert this. I have this one here. So my slope is equal to change in voltage all over change in current. And that's equal to, so this would be equal to, of course, V2 minus V1. I'll just come here and include V2 minus V1 all over X2 minus, all over C2, I2 minus I1. Alright, so it becomes V2, voltage V subscript 2. Let me include 2 there. V subscript 2, V2 minus V1, V subscript 1 all over, if you check, our current was I, so I'm going to use I to represent currents. So it becomes I2, I subscript 2 minus I1, that's I subscript 1, that's I1, okay, I subscript 1. Alright, so I have this, so V2 minus V1 all over X I2 minus I1. Alright, so I'll just insert this. Alright, so you can see this here as V2 minus V1 all over X2 I2 minus I1. Alright, my next task now is to find the values, these values, and impute them. So that would now still be equal to, let me get these values. Let me get the values of V2 and V1 and what have you. So what's the value of V2 for my graph? I'll come here for my graph here. V2 is this one here, which is 1.4. My V1 is this point here, which is 1.2. So it becomes 1.4 minus 1.2. So this is V2, this one here, 1.4. This is V1, that's this one here, 1.2. So it becomes 1.4 minus 1.2. So I'll come here, 1.4, 1.4 minus 1.2. Let me go get my I2 and I1. I2 and I1 go. Alright, so for my I2 becomes this part here. This part where this is coming down. So this part here is 0.05. So this becomes my I2, 0.05. My I1 becomes from here, traces downward. I'm having 0.25. So I2 is this point here, 0.05 minus this point here, that's 0.25. So I'm having 0.05 minus 0.25. So 0.05 minus 0.25. Alright, so I'll just insert this there. I'm having this. Alright, so that's now equal to, alright, so I'll just punch this with my calculator. If I punch this, what do I get? So let me try using my calculator. So I have 0 points. Using my calculator, what do I have? So I have 1.4 minus 1.2 all over 0.5 minus 0.25, and that's about 0.8. 0.0. So I have 1.4 minus 1.2 all over 0.05 minus 0.25, and that gives me -1 as my slope. That's equal to -1. Alright, so this is my answer. My answer here is -1. I think I'm done with this. Let's go back to this now. Alright, so I'm done with this part. So alright, so my answer here is -1. And if you look at my graph sheet gave me my answer as what there. See, it gave me my slope here, as you can see, as 0.988, which is approximately 1. Alright, so me having -1 as my answer is just because of course there are some errors here. If I should zoom in, it's human error. So you can see, if you look at this clearly, look at this clearly, you see that there are some spaces. You can see there's some spaces here. Look at this, there's some spaces here. That means my work, I didn't actually get my points correctly. That's why. But then the software has done it for me, and it's about 0.98. So even if you look at it, 0.98 and 1 are the same thing. So I'm still good. So it got this as minus 0.98. Me, I had -1. So yeah, we are still on the same page. So just for clarity, I'll use their own figure, and their own figure is -0.99 approximately. Alright, which is almost the same thing as mine. So I'll come and use -0.99 instead, -0.99. Alright. So the error was just simply due to what's it called? Was just simply due to my own error, personal error. Alright. So having said that, now what is the SI unit of the slope? If I plot voltage against current, what would be my SI unit? Well, from Ohm's law, let me come down a bit. From Ohm's law, we said V is equal to IR from Ohm's law. So if this is true, that means if I divide both sides by I, divide here by I, divide by here by I, that means voltage against current should give you what there? Resistance, which is R. And resistance is measured in ohms. So that means my SI unit is in ohms. So becomes -0.99. Let me insert ohms. So it becomes ohms. Here's a symbol for ohms, just in case. Right, so this is 0.99. This is a symbol for ohms. So I'll choose this, right. So I have this. So my slope is now -0.99 ohms. So that's the B part. Determine the slope of the graph. That's done. Alright, so what's next here? Next thing here says determine the EMF of the cell. How do you get EMF of the cell? Okay, so I'll show you how to get EMF of the cell from the graph. So C part, let's go to C. C part says determine EMF of the cell. Okay, so C part, EMF of cell, EMF of cell. But let's get this done. How to get EMF of a cell? Let me show you. Okay, it's equal to. So let me show you how you get the EMF of a cell from this. From your graph sheet to get the EMF, just go to your graph sheet there. The EMF is where it cuts the y-axis, please. So where it cuts the y-axis is your EMF. So I'll come here and do this. So if I look at this, it cuts the y-axis at this point here. Again, luckily for me, the software shows me the point here. So mx plus c. So from here I can see that it cuts my y-axis. That's this point here. This is where this is where the EMF is. So look for this value. Trace this one I just drew here. This one here. This one. Trace this value on your graph sheet. See where it cuts the y-axis or the voltage axis. That becomes your EMF. From here I'm seeing that it cuts the axis at 1.449, which is approximately 1.45 volts. Okay. So I'll come here and say my EMF of the cell is equal to 1.45 volts. Please, this value 1.45 is here, this point here. So I traced it from my graph and it cuts this line of best fit, cuts my graph at 1.45. So that's how I got this value. So that's how you get it. So for yours, trace this and see what you get. All right, one last question there. So that's how I get the EMF from my graph. The D part, one last part there, the D part says we should find what there. Go back to my question. D says determine the internal resistance of the cell. Internal resistance of cell. Internal resistance of cell is equal to. So how do you find internal resistance of cell? Now here's what to do. I'll come here. From your graph, please note that your internal resistance is simply equal to the slope of your graph. That's it. Or should you say negative the slope? Let's say. So note that internal resistance of a cell, that's small r, is equal to, that's what to note, is equal to minus the slope. That's all. And this will be equal to minus, my slope is 0.99 ohms, so it becomes minus into brackets 0.99 ohms. Okay, let me just, so if I do minus minus, that will be equal to what there? Positive. So it becomes plus 0.99 ohms. So I'll include ohms here. I simply include ohms here. Alright, so this becomes the internal resistance of the cell. So this is how you answer this question. Alright, so this is the question and this is the solution to the question. Alright. For more content like this, make sure you like this video, please share it to your friends, and also subscribe to this channel for more contents. So I'll take you back to your graph. So this is the graph sheet again. Don't forget, so this is our graph sheet. Alright, so this is the graph and this is the solution to the graph. Alright, so but please make sure you practice this, get a graph sheet and practice this, see if your answers are exactly this. Please, your answers may not be exactly this, but they will be close to this, because mine, I'm using a software and my software is giving me accurate results. So for yours, you might get something close to this, just like I got 1 minus 1. You could also get minus 1. It's still correct. You can still work with minus 1. It's still correct. Why mine is this correct is because I'm using a software. All right, so this is how we solve this question. For more content like this, make sure you like this video and subscribe to this channel. Also share to your friends so they can also learn from this. All right, so see you in our next class.